Bro, yeah, that problem
Okay, folks.
I put R over X.
So we have a really quick lesson today.
Yes.
A quick lesson. Let's get into it. If you'll open up your packet, we're doing this page.
Now we're talking about the graph.
Talking about the graphs. Yes. Okay, ready? So today, I think many of you have familiarity with a couple of things we've done. We're going to be building two different functions, graphs of two different functions. And if you already know how to do this, just follow along. There's several people who haven't done this yet, so I'm just going to build the sine and cosine functions. But I first started with just a few points. One thing that bugs me about this chart, right? They have what, 12 different values. I think one of the most important ones is missing. So I'm going to sneak in right here. I'm going to put 0. We know that sine of 0 is, what is it?
1.
It's one of those. Is it 0? Is it undefined?
I believe it's 0.
Is it 1?
No, it's 0.
Well, I wonder if I could get that information anywhere on this page. Are you sure? You want to bet? Yeah, it's 0. It's right there. It's a y. It's a y coordinate. So that's 0. I'm not going to do all of these, but I'll do pi over 2. We know the sine of pi over 2 is right, undefined. Good. Sine of pi is 0. Then I'll do 3 pi over 2, which is -1, and then 2 pi back to 0. And for those listening at home on this, that when I said undefined, that was a joke. Sine of pi over 2 is actually just 1. And I could take these values and plot them on this graph. Like sine of 0 is going to happen right here. Sine of pi over 2 is right here. Sine of pi is 0. Sine of 3 pi over 2 is -1. And sine of 2 pi is 0. And these all come from the unit circle. They're all available to you at any time as long as you know the unit circle. Now, the graph that we are making does look like this. I'm going to be picky about this, folks. I'm going to be picky. I'm going to tell you what I'm going to be picky about. Take a look at what that slope looks like right about here. What does that appear to be? It appears to be linear, but specifically with a slope of 1, doesn't it? If everything's even, the x and y coordinates, if those are, the x's are even, then that is actually a slope of 1. And over here at pi, that would be approximately a slope of -1. So I don't want to see extreme climbs. I don't want to see this when you're making your graph. I want to be chill. I want to be smooth going up to that 1. So when we graph it here, it's going to look something like this, right? Just kind of smooth up to that. And that curve is just going to be repeated 3 more times. Does that make sense? That exact same curve will be repeated 3 times with reflections. So this next one's going to be here, go on to that. And then to this.
Maybe add extra points or something.
You don't need to. These are the 5 key points that I'd be looking for in any graph. But take a look at my pi over 6. You notice what happened just coincidentally? 1/2. Isn't the sine of pi over 6 1/2?
Yes.
All right, so I'm not doing anything crazy like going up here. I'm not doing it. So please be mindful of your graph. Nothing extreme. Okay. It has some properties. It has a midline, of course, which is a line that goes right through. the middle of it, it has something called an amplitude, which is the
Distance from the midline.
distance from the midline. And remember, the word distance means we're only talking about what kind of numbers? Positive numbers. So amplitude is always, always, always
Positive.
positive. It's sometimes one. In this one, it's one, but it's not always one. Period. For this, does it make sense? The period for the sine graph is 2 pi. We know it's 2 pi because
2 pi.
coming from the unit circle, it starts out over every 2 pi. Just it's a cycle. So it repeats. And frequency, I'm not going to think about that as 1 over 2 pi. I'm going to think about this as the reciprocal of period. It's the reciprocal of period. That's how I'd like you to think about it. Cool. You just flip the period. Okay, so here it is. Let's do cosine. And again, I'm gonna sneak in a 0 there. We know that cosine of 0 is 1. Oh, nice. I'll let you do the other 4 key points here. And you got it? And it's the same 4 curves, isn't it? Do you know what I mean by that when I say the same 4 curves? Yeah, it's reflections of that first arc that we started with. Please be very careful. If I see this point, you see the problem with that?
No points.
No point. I see the problem with starting like this.
Because it goes above the
It goes above that 1. How do we know that cosine doesn't go bigger than 1? I mean, the radius is 1. All these values come from the unit circle. There's no bulge on the unit circle or suddenly, oh, I'm going out there. Yeah, so I never want to see that height of that cosine higher than what the amplitude should be. So please be mindful of that. I have this down here. Oops, I missed it. And so this is, of course, the cosine graph. It looks like this, and it has all the same kind of features. The midline, there's amplitude period, and the frequency is the reciprocal of the period. Now, did you all bring your pocket parabolas today? There you go. Someone brought her. Thank you, Nias. Okay, yeah. And you know, I'm a big fan of showing the graph rather than drawing it out sometimes. So we need a pocket sine wave. The way this works is you take your left hand and put it down, and then take your right hand and put it up, and it connects like that. There's your sine. Do you see it right in front of you? From your point of view, you see that there's a sine graph, right? Does it match? If your left hand is down and your right is up, you have a sine graph. Pretty, pretty. And this works because now when you do like a horizontal stretch, you could do that, can't you? Horizontal stretch, you kind of be like, or a vertical stretch, you could imagine that, or translations. So we can do those. Cosine's a little bit more problematic. It's a little bit problematic. Do you see where your cosine might be?
Oh my gosh.
Yeah, it's tough. It's tough. And you could use the big one. But that's a little bit much. So what I do is I do what's this called in Hawaii? A shaka. Yeah, a shaka. I do a shaka. And it's not perfect, but you can see that from a middle, it goes up, and goes down. But don't try to, like the thumb, can get concavity. Don't try to get some concavity out of your pinky, please. Please. And don't poke yourself in the eye with your cosine. Please. Okay, there you go. And you can imagine like a reflection over the x-axis here with the cosine over the x-axis. It would just be that shaka going downwards or flipped downwards. Okay, this word here, do you know this word? Yeah, there are two correct ways to pronounce it. Either sinusoidal, that's what I normally say, like your sinuses, sinusoidal, sinusoidal. And the other correct way would be sinusoidal. Sinusoidal. So whatever you want to say is fine. There's no I before sinusoidal. So what this is saying that is that cosine is equal to this. So if we, you don't have to circle that, but if you look at your sine wave and then think of sine of theta plus pi over 2, that plus pi over 2 is just is 90 degrees. And for the graph, it is a shift to the left by pi over 2, which means we're just going to take this and go pi. Well, let's say I'm pi in radian mode, right? Because we have pi. And you see that that turns into a cosine, doesn't it? Like you just move it over. Right. So any function that could be changed into a sine, basically cosine is called sinusoidal. There is no cosinusoidal function. You you see it? Yeah. Oh my God.
Okay, so that is sine of pi plus pi over, wait, the sine of theta plus pi, which is that gives you a cosine graph.
That's exactly the same thing as cosine.
Oh. Wait, you said sinusoidal was a simple definition. What is it? It's just like,
Oh, it's any function that could be written as sine or translated into sine. Yeah, few transformations could be brought into sine, which only involves sine and cosine. There are no secret other functions that are sinusoidal. Okay, so with this, it's up to you to determine from this graph the period, the frequency, the midline, and the amplitude. You could discuss with your neighbor quietly if you like.
Wait, don't tell me they know.
wait, I'm not. Like,
Well, it's funny, good one. So we have 2 pi here, and we have pi and a half. Is that one? Yeah. So period is pi. Frequency. Period is midline.
No, it's not.
No, maybe it's
That is, oh my God, I'm stirred.
Wait, period is pi. So like, yes.
Yes, it is.
If you want to start.
It's one of them.
Thank you.
Are you ready? On the count of 3, I'd like to hear the period. 1, 2, 3. Are we good with that? And that's just visually, isn't it? And you counted from where to where?
From the point 0 to where.
You count 0 to where it started over?
Yeah.
And of course you didn't end here because that's not the repeated cycle. You had to go all the way to pi to repeat that. Okay, on the count of 3, I'd like to hear the frequency. 1, 2, 3. 1 over pi. Yay. Midline on the count of 3. 1, 2, 3.
Y equals 3.
Thank you. Y equals 3. I need the full equation. Y equals 3. And can you please show me the amplitude? Show me the amplitude. Yeah, that distance is 3. And we could draw in that midline here if we wanted to. And I may be asking you to do that on tests or quizzes, right? That'd be Y equals 3 right there. So you can see that 3 up, 3 down. Yeah. Yes, Max.
What does frequency show?
Frequency, good question. For right now, and we'll be delving into this a little bit more later. For right now, it's purely the reciprocal of the period. For frequency, it's how frequent something happens. And we'll get there. Yes, Emma.
The reason why it is 3 and not 6 is because, like, if it were to, like, go to the 0 and then -6, that would mean that there.
Well, amplitude by definition is the distance from the midline. So we could see it here. It's this distance, which is 3. This is a great question. Thank you. This distance is 3. That 6 would be kind of like the size of the range. It's involved with the snuff amplitude. If you haven't done 2 and 3, I'll give you a chance to do that. I'll be calling on 8 people to help us with these.
Like this.
Frequency. Oh. Is. Wait, yeah. So it's two. Oh, yeah, it's one. All right, let's check out number three. So there's word focus for maximum. All right, somebody's working.
Example.
Alright, then, okay, we're going to do the half that right. We're going to do five. Actually, no. No. Other way around, sorry. The minute, the two high. So. I don't know. 10.
That's five.
The midline was five, right?
Three.
Midline's three. That's fine.
Yes, midline's three and.
And it's three. Just call me exactly.
No.
Wait, how did
Okay.
you do it?
No, I'm good. Okay,
I
I'm
believe-
saying why. Okay, close suspicion to me.
Oh.
You came to the conclusion like 2 seconds later, that should be another two high. So
basically-
midline. Because you find the distance. Six by
Oh,
It's 10, okay.
Where?
three.
Kidding?
And then you can see where it is. All right, I got it. How do we know what the midnight? Yeah. Yeah. It's just, look at the west side.
Look, 1, 2, 2.
Are you about ready? Ready or not? Let's see what you got for period. Nathan, what'd you get?
The period, hold on,
It's the first one. Should have written it down or something.
sorry, I accidentally skipped to the next one.
Ah,
Wait, hold on 1 second.
I know it's a toughie.
It's a rough.
Well, let's start here. Let's start together. Let's start at the zero. When does it repeat from here?
It repeats. Oh, yo, wait, you missed it. That's how.
Oh, so is that the period?
Yeah.
Okay, there we go. There's the period. I don't know what's going on over there, but 5 or 2 is early. Are we good with that? Okay. Simran, look at that. What's the frequency? How'd you do that?
Period.
Thank you for not saying 1 over pi over 2, right? You just flip it. Perfect. Thank you. Midline. Mia. Y equals 1. Do we agree? Thank you. Yes, Simran?
That, like, because you just calculate how many units there, I don't know how to explain.
Well, let's see what Nia did. What'd you do? How'd you get y equals 1?
Just 3 and
Okay. So then the y equals 1.
one and -1.
We kind of like that. Perfect. Right? Mid being kind of the key part of that word. We're not breaking it up into 1 and 3. Perfect. Thank you. Very nicely explained. Would everyone please show me the amplitude? Show me the amplitude. It should look like Woodstock in here. Nice. Y'all know Woodstock? The 60s music festival. Peace. Example 3. Period. I need some help here. Connor, help me out here. How do you do this? What's that?
4 pi.
4 pi. How'd you get that?
Because the maximum's at pi, the minimum's at 3 pi. So the next maximum will be at 5 pi. 5 minus 1 is 4.
Does that make sense? We have a max here, not that max. We have a max here to a min here, so that's 2 pi. To get back to the max,
4 pi.
it's another 2 pi, so 4 pi total. And we're trying to go back to that, which would happen at x equals 5 pi. Right, it's doing something like this. excuse me, it's quick sketch. Yeah, okay, so yeah, 4 pi. Thank you. Miley, the frequency, please. Thank you. Was that tough? Yeah, quite straightforward. Yeah, the question is, what is frequency now, right? It's a good question, and we will get to that. Midline, Oliver. Do we agree? Thank you. Would you show me the amplitude, everybody? Nice. 5, perfect.
How did you get it, Sure.
Okay. Hey, example 4 looks similar.
Oh, I like.
You're gonna love it now. Take a moment to read through it, but different questions, the same problem. Let's keep the talk to nothing for now, just process. Just. No talking for now. I'll give you a chance a little bit later. Your A, B, and C. Want to start quietly checking in with your neighbor? Now's a good time. Making sure we're all in the same boat. The coordinates you wrote for F are 0, 1, 28. Are we all in the same boat there? Okay, just making sure.
But don't we start there? Yeah, so then that means that it's one. No, oh. No, we start. Oh.
You ready?
I have a question.
Yes.
When is the
standard one
graph of one degree?
Yeah.
That's the third question. We'll get there. Okay, that's a good question.
How they see one?
Oh. Oh. Well, we'll get there.
See one is
Okay, I'd like well, let's talk about this. After F, what's the next point that you labeled?
G.
Did you go right to G? Right, P, right? Isn't that the next one? Just conceptually. And P would be at
30.
30, 128. After this, maybe the next one would be,
G.
J.
I'd probably go to J, but you could go to G if you want. And so we know that G is 15, comma
112.
112. Yes. And then I think at G would make sense because X coordinate is 7.5 and 120. I guess we could have very easily done that 120 immediately, but 7.5 is just a little bit of calculation. And K, the X coordinate is 22.5, comma 120. Okay. Period, frequency, amplitude, and midline for the graph of H from the one and only. I want all of these, please. Judy.
So it is eight and then line is y equals 120.
Any questions? Nicely done. Okay, now C is asking for two intervals for which the graph of H is both decreasing and concave up. Could you show me the shape that we're looking for? It's decreasing and concave up. Yeah, we're looking for this, right? Decreasing concave up. So we'd like to help us with this. Is Augie.
So first, the interval is 7.5 comma 15.
Oh, nice. Let's let that sink in. Does that make sense? He's talking about the X values there for this interval. And that's how we talk about intervals of concavity to these X's. Now, are you including the endpoints or not including?
Wait, I included them, but I'm not really sure why. Like, I think I would like say yes, because I don't think there's a reason to not include them, but I can.
Okay. Well, what do you think? Should we include them? 7.5? Should we include it or not include it? Vote with your thumb, please. December not calling, I promise. Should we include the endpoints for this interval? Yeah, if we're talking about increasing and decreasing, I think at 7.5, it's neither increasing nor decreasing. I would personally not include them, but you may if you wanted to. Simon and then Jonas. Oh, I answered it. Okay. Yay. Yes, Jonas.
Can I give it another?
Well, Augie's answering. If he gets it wrong, then you're the backup.
Oh, I had a think with it. August first.
Yeah, after. Yeah.
Well then, like, since I don't think we marked any other point where it's decreasing and concave up.
Yeah.
I had to go to like the part that we haven't marked.
Okay.
So that would be from 37.5.
Wait, why 37.5?
Because it's like the point, it's like it's like exactly one period from the point that's decreasing.
Does that make sense? Just add a period to that. Okay, so 37.5 and 45. So we don't actually have to draw it, do we? We know it's going to be the same. It's because this function is, what's it called when it repeats? It's periodic. So just add that period. It's going to be exactly the same. Jonas, did you have something to add to that, or was that doing the same?
A bit of like a obnoxious answer.
Sure, if it's short.
Could you say that 814 is also another interval?
8 comma 14. Oh, interesting. Oh, so you're within, like in here?
Yeah.
That's interesting.
Can you say that on a test?
Would that be acceptable?
Technically, but I don't know.
Like this one and the 8 comma 14?
We should vote on it, two separate.
Yeah, let's vote.
He's right, but I don't like it.
It's not wrong. It's not wrong. I feel like it misses the spirit of the problem. I'd probably give you partial credit and definitely points for creativity there. We're looking for a full interval of decreasing content. But thanks for cleaning that up now, because otherwise someone might do that during a test and hope that they have the correct answer. 100%. Yes.
So if I said 10, 10.1, I would get partial credit.
I'd give you partial credit for that because you aren't wrong. Yeah. Any little snippet of that. From 10 to 10.0001. I would definitely laugh. I would definitely laugh and be appreciative of your creativity if you did that. Are we clear on this stuff? Pretty straightforward, isn't it? We're going to break this down a little bit more later on. For today, you have time to work on your assignment. I'm going to go ahead and broadcast it up here. It's not on Pearson. I'm sorry. Next time will be Pearson, I think. I was thinking it'd be today, but not yet. If I ask for them, then you'll give them to me.
My twos are all like different.
Oh no. Shore that up.
I kind of looks like this.
It's pretty. Make sure it's all on the same place.
Which one is it?
On
This is 3.3, 3.4.
It's online.
It's